Hello, welcome back. As you may know, memory holds code and data for the CPU to process, and the input-output ports are used by the CPU to access input and output devices. In the microcontroller, we have two types of input-output. They are the general purpose input-output, also known as GPIO, and the special purpose input-output. The GPIO, or the general purpose input-output, are used for interfacing devices such as LEDs, switches, LCD, keypad, DC motors, etc. Special purpose input-outputs have designated functions such as analog to digital conversion, digital to analog conversion, timer usage, and universal asynchronous receiver transmitter, or the UART. So we're going to find on our microcontroller the same pin being configured as either a GPIO or a special purpose IO, and we would have to tell the microcontroller that we want to use this pin for a special purpose, or we want to use it for its normal general purpose. Right. In a microcontroller, pins are grouped into ports such that we have port A, port B, port C, etc. So each port has a number of pins. For instance, pin A1 stands for pin 1 of port A. In the same way, if you see a pin such as this one, pin E3 stands for pin 3 of port E. So when we're accessing these pins, we've got to tell the development environment, the port, and the pin number as well. So all microcontrollers have this naming convention. They've got the pins grouped in ports, right? But when you're using platforms like Arduino and Mbed, you wouldn't need to indicate the port of or the pin. The Arduino wrapper and the Mbed wrapper has taken care of all of that, and they've renamed these pins into simple names such as P1 through pin 30, P1 through P30, without indicating whether P1 through P5 fall under port A and then P5 through P10 fall under port B. When you coding in Mbed or Arduino, you need not worry about all of that. But when you are doing bare metal coding, you need to know the port as well as the pin number of the particular pin you want to access. Now let's talk about buses. So modern day Cortex microcontrollers have two types of buses. They've got the advanced peripheral bus, and they've also got the advanced high performance bus. The advanced peripheral bus is often written as APB, and the advanced high performance bus is often written as AHB. And when using the advanced peripheral bus, you require a minimum of 2 clock cycles to access a peripheral. But with the advanced high performance bus, you can use even 1 clock cycle to access peripherals. And we're going to go into the data sheet of 4 different Cortex microcontrollers from 3 different vendors, and we'll see that these buses exist in all the microcontrollers, whether it's a microcontroller from NXP, whether it's from Texas Instruments, or whether it's from ST. They've all got this. So let's take a look at the data sheet and locate these buses, because one of the purpose of this course is to enable you to be able to go through the data sheet and the user manuals of any microcontroller you're dealing with in order to work with peripherals and deal with things on your own as you improve your embedded development skills. Right. Now let's see how to locate the data sheet of our particular microcontroller and take a look at the bus structure in the microcontroller. So I'm just going to go to Google and just search the name of the microcontroller followed by the word datasheet. I'll come over here. So let's start with the STM32. I'll say STM32F411RE. The version of F4 microcontroller on my discovery board is this one, the F411RE. But you can search this or search the F40 version. The information should be the same, really. So I'll just select data sheet here, and I can click here to go to the ST website, and They said they've got download data sheet over here, so I can click here and this opens. Right, so there's the data sheet and there's the reference manual. The data sheet gives a summary of the particular MCU. It tells us the number of peripherals, the power consumption limit, and things like the block diagram. You can think of the data sheet as the summary and the reference manual as indeed the reference manual. So the data sheet over here has 149 pages. The reference manual often has over 1,000 pages. Right, so I'm going to scroll down here. We should have the block diagram down here somewhere. The block diagram of the system. Okay, here we go. So I'm just going to click here to zoom, and over here. So this the diagram of our microcontroller, the block diagram, and as you can see, it's got AHP bus here. This is the AHP bus, and anything you see connected to this shows that we can connect to these peripheral using the AHP bus. For instance, we can connect to, for instance, GPIO port A can use AHP bus, port B can use AHP as well, port C, port D, port H can use AHP. Right, but it's not always the same for all peripherals. This one here is an APB bus. As you can see, the name indicated here, APB1. We've got APB2 here. So when coding, we would keep in mind that we cannot initialize, let's say, the UART or the USART2 and try to initialize it using the AHP bus, because USART hasn't got AHP bus. We work with the USART using the APB bus, right? So this is the bus structure of the STM32F4, and we'll be revisiting the MCU. Like I mentioned before, one aim of this course is to give you the skills that would allow you to navigate the data sheet and the reference manual to solve your own problems as you improve your embedded development skills. So this is the STM board. Right, next we're going to see other 3 boards, all based on the ARM architecture, but from different manufacturers. And you see that they've all got the AHP and APB bus. Okay, so I'm going to come over here and I'm going to go to Google and I'm going to search TM4C123 GH6PM, and I'm going to say datasheet. This is the TIVA-C board from Texas Instrument. I'm going to open this, and it's open over here. So over here, the datasheet has over 1,000 pages, but it's fine. We still locate what we're looking for. Often the block diagram is somewhere below the table of content and the list of figures. So you just need to scroll down, and sometimes, in fact, they don't call it block diagram. They've got different names for this. One way of searching quickly is to press Ctrl and F together and search the word you're looking for. So I'll just say block diagram over here. So over here it says Cortex M4F processor block diagram. So the F here means the Cortex M4 has a floating point unit as well. Not all Cortex M4 have floating point units. So this is the CPU block diagram we have over here, but we don't want a block diagram of the processor. We want the block diagram of the entire microcontroller. Remember, the processor is just one part of the microcontroller. Right. We can come over here, TIVA-C series overview. Right, under the overview there should be a diagram. Here you go. Okay. So over here, this is the diagram for the Texas Instrument board, the TM4C123. As you can see, we've got the Advanced High Performance bus, the AHP bus here, and we've got the Advanced Peripheral bus here. In the same way, only those with the arrow connecting to the AHP bus can use the AHP bus. Those without the arrow connecting to the AHP bus cannot use the AHP bus. So let's see an example of what I mean. This is the AHP bus we've got over here. For instance, this peripheral known as SSI cannot use AHP. As you can see, its arrow is pointing to the APB. Right, and this ADC here, this analog comparator here, is pointing to APB. In the same way, the 12-bit ADC is pointing to APB. And we have the DMA. The DMA is able to use both the AHB bus and the APB bus. Right, and we've got a timer here, the watchdog timer, using just the APB bus. We'll talk about all of these peripherals later, so you need not worry. This is just to show you the bus structure that exists in the various microcontrollers. Okay, so let's see the third microcontroller. Let's try the one from NXP. I'm going to search NXP, the popular LPC 1768 microcontroller. And yeah, this is the embed board. Yeah, but we want the data sheet. You can see user manual as well. Okay, so I open the user manual for LPC 176X/5X. So I'll search the user manual for LPC 176. Okay, and it's open over here. This is it. Right. In the same way, we can just do Control F and block diagram here. So this is what it means to be an embedded systems developer. You should be able to work with any microcontroller you're provided with. Often people keep themselves in their comfort zone, thinking, okay, because I work with just ST microelectronics, it's going to be hard to switch to a different vendor. But that's not the case. If you know how to use the data sheet and navigate things like the data sheet and the user manual, you'll be equally comfortable working with microcontrollers from different silicon manufacturers. Right. So, okay, we've got this. It says simplified block diagram. And as you can see, we've got the buses here. And this over here, this bus comes here. And this, they've got, in their system, they've got the multi-layer AHB matrix. So this bus here is an APB matrix, and there's AHB to APB bridge. There's a bridge here. As you can see, all of these peripherals use the APB bus, hence they are called the APB slave group 1. These peripherals use the APB as well, and there's an AHB to APB bridge over here. Right, so these are core Cortex M standards. They exist in all Cortex processors,